Hello, everyone, and welcome to this chapter of the free Dart course. In this chapter, we're going to be talking about isolates. And Dart is so easy to use with its async and await asynchronous programming model that it has made isolates ironically isolated, in that a lot of programmers don't really go in depth with isolates, and even if they do, they look maybe just at like the surface of how isolates actually work, read the documentation, but they never really use them. Isolates are very useful in asynchronous programming, and to make sure that your, for instance, Flutter application's UI isn't lagging. And we will talk a lot about isolates in this chapter and have a look at three particular examples where isolates are useful. So isolates are non-shared memory threads of code that can run in parallel. And if you're familiar with asynchronous programming from before, you probably know about the concept of processes and threads in computers in general. And processes are kind of like a specific program running inside your computer, and it will have its own memory pool. And inside that, excuse me, inside the process, you will have the possibility to spawn new threads. And those threads will share the same memory as your process. So inside that process, you can share memory between your threads. And isolates kind of work like processes. I mean, the official documentation for isolates say they are like processes or threads, but for me, it sounds a little bit more like that they are processes. So, and this is not an official statement from the Google Docs. And I put it here actually. So they have their own memory pool, and they will also have an event loop. Now, an event loop inside an isolate is simply, I mean, you just think of it as a function. So let's say that you have a function that is carrying out the actual functionality of your isolate. In this function, you start at a point, so as let's just say at the first line of your function, and you're able to carry out your work, and you can even do asynchronous work inside that function. You don't have to return immediately. So this function could easily be an asynchronous function, and you will do your work. You can take, let's say, 10 seconds, 20 seconds, 30 seconds of time, whatever it is that you need in order to do your work. And you may even have a loop, and that's why it's called sometimes an event loop. And you can listen to incoming messages, for instance, from a source, let's say socket.io, and you can respond to them. And they're, for me at least, isolates are kind of like two-layer mechanism of the actual entrance to the isolate, which is a function that usually returns a future or a string. This entrance will then create your isolate. The actual isolate code won't be inside this entrance. So in this chapter, I tend to call it the entrance and the main event loop of an isolate, where the entrance is the function that you call, which in itself then spawns a new isolate. And that isolates code itself, where the main event loop actually happens, I usually call it the main function. Okay. A typical Dart application, or let's just say Flutter application, you have your main event loop inside your main isolate, and that's what happens inside your main function. So if you've ever wondered why you have this little main function inside your Flutter applications, that's where the run app, when you call, for instance, run app, and the run app then spawns your event loop and your main isolate for you. The event loop of an isolate is very simple. As you can see, you literally start, there is a loop, or even maybe not. Maybe there is no loop. Maybe there's literally just one asynchronous computation in there. And then you exit. That's it, really. It's very simple. The start is not marked by anything in particular. The start is the beginning of your function. The event loop, or your events, is what you're doing in the function from line 1 to almost the last line. And the exit is you explicitly writing isolate.exit. So isolate's API will dictate basically how you need to use them, and the exiting of an isolate needs to be marked explicitly. So really the anatomy of the main function of an isolate is a simple function, nothing specific about it, nothing special about it. It just ends with isolate.exit, which exits the isolate as its name indicates. So sometimes you may have noticed in your, for instance, Flutter applications. Now, I don't want to go too much into Flutter since this is a Dart course. Sometimes inside your Flutter applications, if you're doing so many computations inside normal functions, which are linked to your main isolate or your main event loop, you may notice some problems with your user interface where it is not as smooth as it should be. On modern hardware, on mobile devices, for instance, you have 60 frames per second refresh rate on screens, and there are so many new screens that are coming out that have like a dynamic range of refresh rates that go up to 120 frames per second when you're scrolling. Now, in order to achieve the 60 frames per second refresh rate on a modern hardware, you need to make sure that you're not doing too many heavy computations on the main isolate or the main event loop. Remember, the main event loop, now, again, I don't want to go too much into Flutter, but the main event loop is usually dedicated to user-driven events. For instance, the user taps on a button or clicks on a button on a website that is created with Flutter, or the user is dragging an image from one cell to another cell, or the user is scrolling through a list view cells or list tiles. So it's mainly user initiated events that need to be handled by the main isolate or the main events loop. So you need to always think that anything you're doing inside your application should somehow, if it's on the main isolate, it should really concern the main isolate, meaning that ideally you don't, for instance, want to parse JSON on your main isolate. So this is something that happens a lot. I've done it. Many other developers do it. You probably don't even notice it that you're doing it. But let's say that you have an asynchronous function which downloads a JSON using async functions, and then you await on the downloading. When you do the awaiting, this is actually going to spawn off a new little isolate for you on the side. You don't know about it, but this is going to then spawn that isolate and get the result back to you. So you're not actually awaiting on the main isolate. So that's really good. However, when the data comes back as, let's say, a map of string, an object, then we usually go ahead and parse that on the main isolate as well. So literally right after that asynchronous function, we're saying, oh, okay, now let's go ahead and parse it. And that parsing is happening on the main isolate. And if you're technical about it, I mean, if you're pedantic, you wouldn't want to do that parsing on the main isolate. It shouldn't really happen because it's not a user-initiated action, really. It's a side effect, usually, of a user-initiated action. Let's say a user taps on a button, in which case you have to go and download some JSON and parse it. So that's kind of like a side effect of the tapping. The tapping itself is something that concerns the main event loop, but the downloading and the parsing shouldn't really affect that main loop and the main isolate. So there are some things called a worker isolate, and that's what we use basically in this chapter. So the worker isolates are simply just isolates that go ahead and do some work in the background and come back with a result. So if you hear the word worker isolate, there's nothing magical about it. It's simply just an isolate that you yourself spawn off in order to calculate and do some heavy processing, perhaps in the background. Every isolate in Dart can send results back to its spawner. Remember when I mentioned that an isolate is a two-part function? It's kind of like two functions, actually. The first function is the entry, and the second function is the main event loop of that isolate. The main event loop will have a port, as its name indicates. It's a tunnel in which using which it can send messages back to the entry of that isolate. So there's a function that spawns off the second function. The second function does the work, and through a tunnel, through a port, can send results back to the first one, and this first one can then send the results back to you, the caller. And there are various things that can be sent back and forth between the spawner and the main function of an isolate. There is a specific object that carries out this work, and this object is able to pass specific objects back and forth. So you cannot, for instance, have your own class, which is let's say you have a very complicated data structure, and you say, oh, I want to send this particular thing with so many different JSON and etc. in it from this entrance function to the main isolate function. There is a documentation for it, so I suggest that you go ahead and read this documentation. As you can see, API Dart stable, and then the version of Dart, blah blah, and then send port send HTML. So I'll actually see if I can bring up this documentation. Just give me 1 second, please. I have it right here, so I'm gonna bring it here. So let's have a look at it together. I mean, we're not going to go into so much detail about it right now, but we will go through this more. As you can see, the send method is implemented on a send port, which is, if you remember, this is the entrance and this is the isolate's main event loop. The send port is a port that is sent from the entrance to the main isolates function. So the send port is consumed by the main function of your isolate, through which the main function of your isolate can then send messages back to the entrance, okay? And those objects that can be sent from the main function to the entrance function are these. You can see it can send null, bool, integer, double string, list or maps, transferable type data, send port, and capability, which is an unforgeable object. It's a little bit special capability. You probably don't use it so much in Dart, or maybe almost never. So you have to be aware of these particular objects that you can send back and forth between these ports. So we will talk more about ports. So don't worry, it's a little bit of an abstract thing to talk about right now. So let's go back here. I'm going to do some reshuffling. The screen isn't that important at the moment. If you're a Flutter developer, you're probably already familiar with a very special function in Flutter called compute. And this compute tries to simplify the usage of isolates for specifically Flutter developers. So Dart can be used for more than just Flutter development, although maybe the main reason you know about Dart is through Flutter, and that's completely fine as well. But you can also do, for instance, backend development with Dart, and I'm sure that there will be a lot more usages to using Dart purely as a language also in the future. If you're a Flutter developer, you've probably used compute and maybe not directly using isolates. And compute like wraps itself around isolates in Flutter and makes the API a little bit cleaner. So it makes it so that you don't have to fiddle around so much with receive ports and send ports. So however, there's a limitation to compute function, and that is that it is not available on Flutter Web, and at least not at the time of this recording. So it is always good for you to learn about isolates themselves as they're supported wherever Dart is supported. And also I suggest that you read the documentation of isolates just to understand where you can use them or where you should use them. So message passing between isolates can sometimes be heavy, and because it involves copying memory contents. However, I mean, there are two ways of actually, before I explain this, there's two ways of passing messages between the isolates entrance again and the isolates main function. The isolates main function will receive a port using which it can send data back to the entrance, as we talked about it. Okay, so there's the main function and this is the entrance. The main function has the ability, and it should, when it's done, call isolate.exit. Isolate.exit exits the isolate and finishes the work of the isolate's main function. And it has the ability to optionally send a message or data packet back to the entrance. Doing that through isolate exit doesn't copy the contents of this message. Doing that actually assigns that message's owner to the entrance function. So it is as an O1 operation. However, if you use this port that we will talk about to send messages from the main function back to the spawner, then the contents of those objects will be copied. So it's a little bit of a heavy operation. You probably don't want to like have such big objects being passed from the main function of your isolate to the spawner. And you kind of want to like keep it to a minimum, keep it really to the absolute necessary objects that you have to pass instead of passing way too much objects, okay? So when you call isolate spawn, as we'll talk about it inside your main entrance function to create the main event loop of an isolate, when you do that, the isolate spawn basically spawns a new isolate in the current isolate group. And we're not going to talk so much about isolate groups in this chapter because it is way more, it's like way past the goal of what we're trying to achieve, which is talk about isolates. And it is very rarely used, at least in my experience, like Dart isolate groups. In the projects that I've worked with, I've never seen anybody having to create their own isolate groups. So they're very special. And therefore we're not going to talk about them. But just know that there is a thing called isolate groups. And isolate groups kind of like put similar isolates or the isolates of your choice into, as its name indicates, into a group, kind of like a process that has threads and really puts like a shell around it. So meaning that data that is inside an isolate group cannot be passed to another isolate of another group. So it's really like processes, and they're inside this environment in which they're very tightly guarded. So if you hear about isolate groups, just know that that's what it is. So let's go ahead in this chapter. Enough about the theory. We're going to put this to use. In this chapter, we're going to create one project. It happens to be a Flutter project, but we're not actually going to look at the screen or anything for like on a simulator because it's nothing UI related that we're developing. There's just one project that we're going to create. In this project, we're going to create 3 examples. So 3 completely separate examples that do 3 separate things. So the first one we will develop, and then we will tag it and commit it. Then it will come to the second one and the third one. So let's go ahead and create our project in here. I'm going to do some reshuffling here, bring the terminal perhaps here so you can see it better. So I'm going to go ahead and in here say Flutter create testing isolates course, and I like to add an organization in here. You don't have to do the organization part. So this is going to create our sample Flutter project for us. And again, I'm creating a Flutter project simply because I really like the hot reload inside Flutter, so that when we change our code, I can just press Command S on my Macintosh or U Control S on Linux or Windows, whatever operating system you're using, and just see the results immediately in the terminal. You don't have to do this. You may just decide to say, well, I don't want to use a Flutter application. I'm just going to go create a simple Dart file. You're more than welcome to do that. That's completely fine. You just have to run your Dart file manually, perhaps. So that's it. Let's go into that folder, and I'm going to bring up Visual Studio Code here. And let's go ahead in here, and I'm just going to say select device. And I have a little IO simulator in here. Let's go to the main function. Sorry, the main Dart file, main Dart. And as the caption at the bottom of the screen says, oops, I'm going to then create a very simple scaffold application in here, okay? So that we can, because I don't need all this code that is generated in the template, okay? So I'm gonna create a simple scaffold application in here. You can see it has a homepage stateless widget. We don't have to know all of this in order to follow along with this chapter. I mean, this is just a simple scaffold Flutter applications, which we're not gonna talk about so much in this chapter. Then I'm going to try to run this application on the simulator. And again, we're not going to have a look at the UI of the application because there's no UI that we're developing. Okay, so what we need in here is, I mean, what we're going to do in this particular example is to do JSON parsing, JSON downloading and parsing inside an isolate, and being able to get the results of that back into our main application or the main isolate. So now the application is running. I can see in here. So what we need really is a simple class for that particular object that we're creating. So I decided to simply go ahead and design a JSON for this, and we're going to put some dummy person objects in there. Persons are going to have age and name. And we will, since we're doing JSON downloading and parsing, we kind of need to host this JSON somewhere. We don't want to put it just inside our applications bundle. And for that, there is an extension in Visual Studio Code called Live Server. And Live Server is a free extension you can download on Visual Studio Code's marketplace, which allows you to turn your current workspace into a server. So it's a local server that will listen to incoming HTTP requests, and it will serve the local files over HTTP. So what you need to do is to go in here and search for Live Server. And I've already installed Live Server, so I don't have to do it again. But if you haven't, then you need to go ahead and install it in order to be able to follow along with this chapter. So let's go ahead and create our JSON in here. So what I'm going to do in here, I'm just going to go and create a new folder, which I believe is this one. And we're going to call it APIs, as I can see in here. Okay. Actually, I'm not going to do that. And I can see it's like creating it in the wrong folder as well. So what I'm going to do is I'm going to right click and I'm just going to say new file. And as you can see in here, I can just type the entire path in here. So I'm just going to say APIs, people want JSON. Okay. Just like that. So we have people want JSON in here, and let's go ahead and add some objects in here. So there's is an array. We're going to start our JSON with an array. And the first object is going to have a name of foo. Let's just call it, I think we call it. I have this entire JSON, so I'm going to paste it in here instead of us having to type it by hand. I mean, the task of writing JSON is very tedious, I find it, and it's not so fun. So I just paste it in here. You can see there's the first person has the name of foo1, and the next person has the name of bar1, and they have different ages. Okay, so here is our JSON. I'm going to save that file. Then what I'm going to do is to bring up the command palette here, and I'm just going to say live server, open with live server. And as you can see now, it created a little live server here. I'm going to make it mobile a little bit. And our APIs folder is right here. I'm going to tap on it and then say people want JSON. You can see it's serving the JSON to us, and it has its own port in here, which is 5,500. On localhost, APIs, people want JSON. So now we have this URL ready to go in our application. Okay. So now that we have this person, let's go ahead and create a class that that we can use in order to read instances of this person class. This person JSON from our JSON file. Okay. So let's go ahead here in our main function, right there, perhaps in between. I'm going to start writing our little class in here. Okay. So let's say I'm going to make the screen a little bit ginormous in here and make it immutable class. I'm going to say class person. Okay. And in here, we're going to have a final string name and then final int age. So these are two simple properties that we're going to create for our person class. I'm going to get help from Visual Studio Code to complete the constructor for this class, make it constant as well. And let's say these both are required parameters, okay? Just like that. going to put a trailing comma at the end. Great. So now we have our immutable class person. Perfect. What we also need to do is to create a little constructor here, which can create an instance of our person class given a JSON map. Okay, because later, as you'll see in our isolate, when we go ahead and parse this JSON, we need to be able to create an instance of this person class using that object. So let's go ahead and create that right now. So I'm going to go ahead in here and say person from JSON. Okay, so let's create that. And we have a map of string, and I believe it is dynamic. And we get our JSON in here. Okay. So now our responsibility in this function is to assign values to our name and age properties from this JSON. So let's just say name is JSON and the key is name as a string. And then age is JSON, age as int. Okay, just like that. So now we have a constructor for our class person. It's called from JSON. It takes a JSON and it spits out a version or spits out an instance of our person class. Very simple. So what we're going to do in here is very simple. We're actually going to start implementing our isolate. We're literally just going to jump right in. So as I said, your isolates are in two parts usually. There are two functions usually. And those two functions, I suggest actually creating it as two functions. You don't have to. You can have it as one function, but I prefer to have it as two functions. The entrance, which sets up the isolate, and the other one is the main function of your isolate or the main event loop of your isolate. So in this, right now, we're going to develop the main function. So we have no function that's actually going to spawn or start it. We just create the function itself. So you'll get a hang of how you create your main isolate function. Okay, it's incomplete because it doesn't have the entrance, but we'll get there. So don't worry about it. So let's go ahead and we're going to call this guy get persons. I'm going to prefix it with an underscore, meaning that it is a private function. So let's go ahead and call it void get persons. And I'm going to mark it as async because it's actually going to do some asynchronous work in here. However, there's a very important parameter that we're going to pass to this function. It doesn't have to be this particular parameter, as you'll see at the third example of this chapter. But a lot of people think that this parameter always has to be of this type, but it doesn't. However, if you remember again to this little simple example that I keep bringing up, you have your isolates entrance, and then you have your isolates main function, which is what we're developing right now. The main function has to have a tunnel to the entrance. So the main function should be able to pass some data back to this guy. And the way to do that usually is with something that we call a send port. Send port is a class in Dart using which the main function of an isolate can pass values back to its entrance. As its name indicates, is a send port. It's a port using which you can send objects to your entrance. Okay. So we call it send port in here, and let's just call it SP as send port. Okay. And in here, you can see it says undefined class send port. So I'm going to get help from Visual Studio Code and see if it can import it for me. It's going to import library Dart isolate. So you have to have that imported in order to be able to follow along with this chapter. Okay. So that's imported for us. So in this function now, you'll see if you type SP, which is your send port, there's a method in here called send. And this is your tunnel. This is how you can communicate from the main event loop, which we're developing right now, to the entrance. So anything you send from this guy gets sent to this guy. And we'll talk about how you can catch that value soon, okay? So what we're going to do is to first go and grab the URL for our person's JSON. I'm going to put the URL in here. It's 127.0.1.0.0.1 and API people 1 JSON. I can click it and you can see it's right there. So define it as a constant. I didn't want to type all of that, so I just pasted it. So let's go ahead and use HTTP client in Dart and grab that JSON and parse it. So I'm going to say final persons, or you can call it people. I'm always confused about people and persons. Await HTTP client. Let's create an HTTP client in here, okay? And it says HTTP client isn't defined, so let's just import Dart.io. because HTTP client is defined inside Dart.io. Okay. After doing that, what we need is we create the HTTP client, and in here we're going to say get, and the get URL. This, and then we pass the URL in here. Okay. And then what we have to do after this is to actually close our request. So we say then, and this is our request object. So this has nothing to do with our response. That's just how the API is. We have to close it for the request to actually be sent. After doing that, we can then get the response. So we're going to say then, this is our response. I'm just going to call it response. Okay. Then what we need is to be able to transform this guy to a string. And for that, we need, let me just bring it in here, we need Dart convert. So let's go ahead and import Dart convert in here. And then let's go ahead and do the rest of the transformation in here. Let me see if I can find my code as well. Okay, so let's say response, transform. You can see here is the function. There's just so much going on the screen. I understand it's a little bit difficult to see, but it's right here, transform. And then we're going to use UTF-8, and we're going to use the decoder right here. And then we're going to join the whole thing at the end. Okay, like that. Boom. I understand. I think Error Lens, I mean, there's an extension that I have on my computer called Error Lens or in Visual Studio Code that highlights all the problems. So I can see in here is also complaint. And this highlighting of all these problems in line can sometimes make your code look like you're doing everything wrong. But really, I promise you, we're just doing a few things wrong in this code at the moment. So let's go ahead and fix those. The first thing is that this URL is of type string. We can't pass it here. It should be URI parse URL. So that's the first error that's gone. And the second problem that we're seeing here is just because we don't have a semicolon in here, but that's intentional because we are not done yet. So after that, we get the result that comes in here is a JSON string. Okay, so I'm just going to call it JSON string. And then let's just say we are going to use JSON, and we're going to decode our JSON string in here. Okay. And this is going to be a list of dynamic, because remember, our JSON is actually a list, and it's a list of dynamic. We don't know its types yet. Okay. So that's that part. Then after getting that, we're going to map this guy. So the list of dynamic in here, let's say then, and we're going to call it JSON. And then we're just going to, in this list, map it to instances of our person. So let's just say JSON map. And let's just say, what do we call it? Map. And in here, we're just going to say person JSON from JSON. And then we're going to pass that map to it. Okay. Perfect. So after writing this code, I'm just going to also await on it because this is a future. Okay. So this is our JSON parsing. Let's see if Dart is intelligent enough to understand the data type of this. So if I say persons, it understands as an iterable of person. So intelligent of Dart to understand and get all of this without us actually specifying any data type really, except until the end. So that's good of you, Dart. So how do we send an iterable of person object back to our entrance? Remember the entrance, we haven't developed it yet, but this entrance is going to sit up here and it's going to spawn this instance of our isolate. And the way to do that, as I mentioned to you, is through send port. So send port has a function called send, and it allows you to basically send that data back. So what we're going to do in here is to use, let's go in here, and we're going to say sp dot send in here. Okay, so you could say send, and then you could say persons. Okay, so that's one way of doing it. However, we're not actually at the moment exiting this isolate. If we do it with send, then there's really, I mean, you're not explicitly exiting your isolate. So this is one way of doing it, but another way of doing it is actually saying isolate. I'm going to bring the code up so you can actually see it. Isolate here. And if I say exit in here, then you could say persons like that. persons. The argument type iterable can't be assigned to the parameter type send port. Oh, I see. So we can't actually, so if I say isolate exit, it needs a send port. So if I go in here and say SP, and then I say persons. Okay, so we have to do it like this. So this is the way to actually exit our isolate, as you can see. So let's go to the exit function. As you can see, it says I require a send port, and then also any object that you want, I can actually send back. Okay. So this is, if we go back to this exit, let's have a look at it. If the port is a native port, here, then the message is sent through that port as the final operation of the current isolate. So we will have a look at catching this soon. So you'll see how this is done soon. So now that we have the main function or the main event loop of our isolate, we have to have a look at how we spawn it, how we actually create an instance of it and communicate data from the main function to the entrance, and then we're going to call the entrance from our main application's isolate. You'll soon see how this is done. So we're going to now talk about spawning our an instance of this main function for our isolate. So let's go ahead, as we created get persons with an underscore function in here. Let's go ahead and create an actual entrance, and we're going to call it get persons without an underscore. So we're going to say void get persons. Okay. Actually, this is not going to be just a void. I believe this should be a future of iterable of person. Iterable, if I can type, person. So like this. And this is just called get persons. Okay. And let's just mark it as async. So this is exciting because this is the main, this is the entrance to our isolate. So this function should set up our isolate and grab its result and send that result back to its caller. So remember, the main function of our isolate needs a class of type send port. However, in the entrance, you don't actually create a send port. You create something called a receive port. And this receive port, it has the ability to expose something in itself as a send port. It's a little bit strange. Let's just type it first. Let's just call it final a receive port. It's a receive port. Okay. So the receive port is used inside the entrance. The receive port is something that you say, hey, I'm a tunnel. I can wait for responses, and I will give you an instance of send port from myself. It's like you give a write-only copy. Actually, yeah, this is a good analogy, I would say. So receive port is read-write. Send port is write-only. So send port is just a medium using which your main isolate function can send data back to its creator. However, the receive port, as its name indicates, not only has a send port in it, but it also has a receive port. So it's read-write, and a send port is write-only. Okay. So now that we've created a receive port, we actually have to spawn our isolate. We have to create an instance of this main function. So let's go ahead and say we await on isolate dot. So let's actually see, create a receive port. I'm going to now jump to the correct title at the bottom of the screen. So we're going to say await isolate dot spawn. And in here, the spawn function, that you have to look at its function signature to understand a little bit better how it works. You can see it says, give me an entry point here that has a void return value. It takes something in, and then as the second parameter, you basically has to send that something into that function. So this is a way for future spawn to actually wrap itself around the entry point. Okay. So remember, the first parameter of spawn should be a void function that takes in a parameter of any type, in this case type T. And the second parameter that you pass to spawn should be that data that your function accepts. Okay. So let's go ahead in here and we're going to say, well, the function name is this. And it says, oh, I expect 2 parameters. And the reason behind that is that, yeah, it knows that get persons requires a parameter of type send port, but we're not sending it. Okay. So let's go ahead and send the send port over, and the send port is inside the receive port. Remember, receive port is read write and send port is write only. So we're going to say rp dot send port in here. And now you can see it is actually quiet. It says, okay, that's fine. However, we still have a little bit of a problem in here. And the problem is that we're not returning anything from our function. Remember, the isolate exit call inside the main function of our isolate, this is sending this person's iterable back, but we're not actually reading that data. Now, the funky thing about receive port is that if you look at a source code, receive port implements stream. So receive port is actually a stream. If you look into the source code, let's have a look if we can find that. You can see that it implements stream, meaning that it can actually receive multiple values. You can await on those values, and you'd be like, okay, but what values does that have? What is the receive port's value? Well, the receive port's value are the receive port's values are the values that the main function sends to it using the receive port send port. So again, let's go back to this example. You have the receive port up here. You have the send port being consumed down here. This guy sends a value, says value 1. This guy catches that value 1 inside its receive port. And then this guy says value 2. This guy says, okay, I got it. And this value 1 and value 2 that were accumulated here, they're accumulated inside the receive port, which is a stream of those values. Okay, so, and again, if you're a bit confused about streams and futures maybe in Dart, it's probably a good idea to go and have a little bit of a look at the documentations of asynchronous programming inside Dart's official documentations. There's a lot of good resources available. Okay, so what we're going to do in here is that we know that this main function at the moment only sends one value back to the send port using the exit function of isolate. So we know that this stream, which is this receive port, only contains one value. So what we're going to do is literally just send that value back. We're just going to say RP first. You can see it's a future. Yeah, we know it's a future because, yeah, it's a value that comes inside the send port. So what we're going to do is just to return a waiting on it, just like this. Okay, so we get the first value that comes through the send port, and we just end the whole thing and just return. That's it. Okay, so let's just save this file. And as I mentioned, there's lots going on in here, I understand. So let's just have a quick look at it. And see what is really happening in here. Let's this time start with the entrance. As you can see, this is your this is the entrance function to your isolate. This is what you will call as a consumer to grab an iterable of your person class. Okay, so you call this, and then of course it's an async function, or it's just a future. You have to wait on it. All right, we understand that. Then you have to create a read and write tunnel using receive port. This is so that you can communicate, so that you can actually grab values from your isolate's main function, which you're going to create soon. Isolate spawn then is a future. If you look at its, you can see it actually creates the isolate for you, and then it returns it back to you. Okay, and you can await on it. In the coming examples, not after this one, when we get more advanced with isolates, we're going to talk about actually use this awaiting of isolate spawn to do some really fancy stuff. But for now, we're just saying isolate spawn, create our new isolate using this main function called getPersons. We know that this getPersons requires a parameter of type send port, and that is why we're creating the send port in here and giving it to you. Okay. Remember, send port is a write-only copy, or maybe not even a copy, it's a write-only version of receive port. Receive port contains a send port, okay? After doing that, we're saying that we know that this receive port is a stream. Its first value is going to be received, and we're going to await on it and return it. That's it. However, the exciting stuff is happening inside getPersons underscore getPersons function, because that's the main body of our isolate. And this guy is saying, okay, I create an HTTP client, and I grab this URL. I close the request so that I get the response. After receiving the response, as you can see, is an HTTP client response. We transform its body to a UTF-8 string and join it, and the result is a string. As you can see, it's a future string. After getting that JSON string, we're decoding it, okay, in here, because then this actually gives us the JSON object. In this case, we saw in our JSON, this is a list. We don't have types. I mean, we could just be more specific about what type of list it is, but we're just saying a list of dynamic. That's sufficient, okay? After doing that, we get that JSON list of dynamic, and we pass it to, you can see we're mapping that because, and then every map will be a dynamic object, which then get passed to person and gets parsed as a person object. The result of this is an iterable person. And we're exiting our isolate after doing all of that using our send port, and we're passing this object back to the send port. Okay, so that's really how it's done. So there's not much more to it. So what we're going to do now is to try to consume this get persons function in here. So let's go to our UI in here and just add a simple button. Let's just call it body text button in here. And I'm going to say onPressed empty function, okay? And then inside here, I'm going to say a child is a const text, and let's just say press me or something. Okay, so missing colon somewhere and like that. So now we have a text button. Let me bring up the simulator. I know we said that we're not going to talk so much about the UI, but I think it's also good to see how it looks like, okay? So that's our button. And in here, let's go ahead and hook that onPressed to our get persons, okay? So let's make this onPress an async function. And in here, we're just going to say final persons is get persons and await on it, okay? Because remember, this is the entrance. The entrance doesn't need to have the send port stuff. It's just it's like a consumable API, okay? Now that we created that, let's go ahead and then just say persons log. And also we need a log function. And I have a good snippet for that. So I'm just going to say log. And you can see I am importing Dart developer and making sure that it's named as dev tools. And then I'm saying show log. Then I've extended every object inside my project with a log function. And what that does, it just calls devtools.log and takes the string representation of that object and just prints it to the development console, okay? That means that in here, I can just say persons.log like that, okay? So now that it's done, I'm gonna clean the debug console. I'm just gonna do a hot restart as well. Let's go to the app UI and press this button. And now you can see after pressing that button, we got 2 instances of that person class without a problem. So that's basically done, really. I mean, the demo time is really just that when you press this button, you're going to get instances. You can see this counter is increasing. So if I clean the console in here, I can just say press me and I get new instances of this guy without a problem. Okay, then, now that we've had a look at how this is working, I mean, we don't really need to look at the simulator. It's not important in here. The important thing is actually calling this get persons function right here and getting the results back. You can do that in a simple Dart application as well by turning your void main function into an asynchronous function and doing the exact same thing that I'm doing here in these 2 lines of code inside your main function. So you don't have to have a Flutter application. It's just, I think, I mean, I like the comfort of being able to do hot reload and hot restart in Flutter to be able to get my code running fast. That's the only reason this is at the moment a Flutter application. So now that that is working, let's go ahead and commit our code and also tag it as we usually do. So I'm just going to say git status, git init, since we're not a git repository, git add all, and then I'm going to say git commits step 1. And then I'm going to say git tag step 1. Okay. So that part is done. And I'm going to go to my notes as well in here, make sure that I can go to step 2. So git checkout Step 2, there's nothing that you have to do. It's just for me to get my notes. Okay, that's really good. I mean, we've done a lot in the first example. It took a while to get there, but I just wanted to make sure that we understand the fundamentals of isolates and how they work, how isolate spawn works and how isolate exit works, and how the receive port, for instance, is a stream, is read write, how the send port is write only. These are some very important aspects of working with asynchronous programming using isolates in Dart. Okay, that was just getting one message back. As you saw in the code, let's go here. And as you saw, get persons is at the moment is only sending a list of persons one time back to its spawner. The spawner was the entrance function. So however, we said that the receive port is a stream. It could potentially receive more than one message. In here, in our example, we're just waiting for the first signal. And as soon as we're doing that, we're just returning from our entrance function. And that completely exits the isolate. Everything is done. So we don't have to do anything more. But that's not the full potential of isolates. And in this example, in the second example of this chapter, we're going to have a look at how to grab, how to be able to continuously communicate between the main function of your isolate and the isolate's entrance and relay that message potentially back to a caller that calls the entrance function. Okay. So what we're going to do is to create an example in here. It will, as you can see, it will send the current date back to us 10 times in a stream of string. So we're going to change this function in here to say that the entrance function is not a future anymore, but it is in fact is a stream. Okay, so this is going to be very exciting. I love like asynchronous programming in general in many different languages, in Swift and Rust as well. So this for me is very special, I would say. It's very exciting to see like streams working with isolates. And one thing that is lacking a little bit online is if you look at the documentation for isolates with Dart and Flutter, which use, for instance, isolate spawn, then they're not talking so much about streams. It's usually a future. I mean, that is quite a bit of a limitation, I would say, because isolates are a lot more than just having a future. You could do that just with a normal async function. So let's talk about how we actually do that. Let's go ahead and delete the code that we've written in here that has the get persons and the get persons underscore in here, and delete all of that. And I'm going to delete the code that is inside our button as well. So we're going to keep the person class only. Okay, and we have some unused imports at the moment. Don't worry about it. We're probably going to use them, maybe not convert. Maybe actually convert. Yeah, probably convert. So don't worry about your unused imports at the moment. So let's keep the person class and delete everything else, okay? So what we're going to do is, as we did in the previous example, is to start off by creating the main loop or main function of our isolate. For me, at least, that's like, that is the better way of going about creating my isolates. First, I focus on what the main function does. It takes in some sort of a send port using which it can communicate back to its entrance function, and it does something. It's a void function, which is asynchronous. Okay, simple. So let's go ahead and focus on this guy at the moment. So we're going to go ahead and write the header of this function. It's going to be called void get messages, I believe, get messages, and it needs a send port. So we're going to say SP. And we're going to make this guy an async function. Remember, this is one of the important things I want you to get from this chapter, is that your isolate's main function does need a send port, but it doesn't have to be this parameter. Do you understand what I mean? This parameter could be another object. It doesn't have to be a send port. You could pass a custom object in here as long as your isolate spawn sends that object to this function. In that object, you could have a send port. So you can transmit data from isolate spawn to your custom main function or the main loop of your isolate without having the send port as the only argument. However, it's very important to understand that this function has only one argument. So you could pack anything you want inside this one argument by creating your own custom class. But one of those things that needs to be inside that custom class is a send port, because you need the send port to communicate stuff back to the entrance function. Okay, don't worry about that. If you didn't get that fully right now, don't worry. The third example, right after this example, I'm going to show you how to do that. And that third example, to be honest with you, is going to be quite advanced. But I also believe that there are not so many advanced examples of using isolates in Dart. So I really wanted to explore that. So if you wanna hang with me until then, I would be really grateful, because we'll have a look at using some more advanced features of isolates in the third example in this chapter. Okay. So now we have the main function of our isolate. So what we're going to do is to create a little stream, a periodic stream in here that grabs the current date every second. So a stream periodic with a constant duration of 1 second. And every second that passes, this guy is going to grab the date time now and converts it to ISO 8601 string. Okay, it's a little bit strange. We'll have a look at it. So let's first create the stream. We're going to say periodic. The duration is going to be a const duration, seconds, 1. So you can see in here. So that's our stream. And every time we go in here, we're just going to ignore the incoming parameter, and we're just going to say date time now, and then we're going to get the to ISO. You can see string in here. Okay, so this is our stream. So if I say final foo, you can see that this is a stream of string. So if I say here foo, you can see a stream, right? Because it's a stream that ticks once every second, and for that tick, it basically grabs the current date time as a string. Perfect. So that's our stream. So what we're going to do is we're actually going to await on this. But before doing that, what I want for this example is not like a continuous stream that never ends, but what we want is a stream that ticks once every second, but it ticks at most 10 times. And there is a really good function on stream. You could say take, and you could just say 10. This means that a stream ends itself automatically after 10 emissions. Okay. So let's go and await on this guy. So we're going to say await, await for final now in this stream. Okay, so now we're waiting for values inside that stream. And what we want is to be able to send those strings back to our send port. So let's go ahead and do that. So we're in here just going to say SP, which is our send port, a write-only copy of our receive port. And we're going to say send. And we're just going to say in here, we're going to send, where is the data for now, right? Like that. So now we're communicating these 10 takes from our stream back to our receive port. Remember, receive port is the read-write version of the send port. Send port is write only. Okay. So after doing that, we also have to exit our isolate. So don't forget that. Okay. So let's go in here and say isolate.exit. And then it says, okay, where's the send port? And then we say, here's the send port. In the previous example, inside isolate exit, we actually sent a message back. Remember, that was our way of communicating with the entrance of our isolate. In this example, we're not doing that. We're not using the isolate exit second parameter, which is optional. If you go to the exit function, you'll see that this object is completely optional, meaning that if you provide it, that object will be the last object in what your receive port receives. I know it's weird, it's strange. Just know that, let's say that you have a stream. I'm just going to put it in a diagram so we can have a look at it together. Let's say this is a stream. This is your send port. I'm just going to call it SP, and it starts here. It continues, let's say, for 3 seconds, okay? And then you say, okay, or just 1 second. Let's say every one of these dashes is a second, okay? So that's 1 second gone, and then you send the value of now. Then another second goes by, and then you send now. And this carries on for like 10 items, or let's just say take 2 in here. So you send 2, so you say, wait, send the current date. Wait, send the current date. And then in here, it ends because you said take 2, only 2 values from your string. And since in here we said isolate, let me just scroll here so we see it. Since in here we said isolate exit and we didn't pass an object, then your stream ends right here. However, if in here you said hello, just like that, then your stream will be like this. Hello, right? So if you provide a value to your exit function as a second parameter, it will be appended to the end of the stream. It will be appended to the end of your output. So that's very important. And if you don't use send port send function like we did in the previous example. So in the previous example, we didn't use the send port, the send function. So we were like this. And instead we use isolate exit and we had a parameter. Then it will look like this. So the isolate will only contain that value that you pass to your isolate exit function. Okay, so remember, if you have a second parameter in your isolate exit, it will be appended to the end of the stream that gets passed to the entrance. So let's take this back to how we had it, to the take 10, and I'm going to remove this little documentation that I put in here. Okay, and the font is absolutely ginormous right now, so it's almost unreadable. So let's have it like this. I think it's a little bit easier to see. Okay, so and that's really it. I mean, we have now our isolates main function. So it's time to go ahead and create like the consumer of this isolates main function. And that is the entrance function. Okay. So it will be the entry point of our isolate, not the main loop. The main loop is already written, called get messages. So we're going to go ahead and now actually create the entrance function. And this guy is going to have a stream of strings returned, or actually a stream of string, not strings. Depends how you think about it. Maybe a stream of string, someone can think that is a stream of list of string, but for us, it's going to be a stream of string. So let's go ahead and write it. So we're going to say stream of string, and we're going to call it get messages. So this is like how I like to do the implementations of my isolates. I first write the main function, and then I go and write the entrance, okay? And I usually separate them like this. So the main function is prefixed with an underscore, whereas the entrance isn't. So the first thing we're going to do in here is actually going to create our receive port. So I'm going to say final RP as in receive port is equal to receive port. Okay, so that's our receive port. Remember, receive port is a stream. So we're going to do something funky with it. Okay, so then you may be thinking, so how do we now go ahead and grab this stream back? So what I like to do is if you remember, isolate spawn function was a future. If you turn that future into a stream, and then when that stream sends its first value, meaning that the spawning has happened, you get your isolate, you can actually turn that stream into the stream of your receive port. It's strange, I know, but this makes a lot more sense when you see the code and when I explain it to you what is happening in here. So let's go ahead in here and say isolate spawn. We know that our function is called get messages, right, in here. And then we're also going to go ahead and we know that it needs a send port. So we're going to say RP send port. Okay, so that's our spawning. So this guy's return value, you see, is a future of that isolate. Okay, you know that there is these then functions in that are implemented on a future, which means that once that future completes, then do something else and turn the result of the isolate future into the next future. That's how we did the previous example. Remember with the JSON parsing, we had so many then. We were literally changing the data type. Isolate spawns future, it actually gives you the isolate that doesn't mean that at that point that this function has completely completed its work. All it means that, hey, I created the isolate, here you go. And then this guy could just take some time to do its work. So let's go ahead in here and turn this guy into a stream first, as stream, like this. Now that you turn this future into a stream, you could change its data type to another string. So every time this guy sends a message, which is just once because it's a future turned into a stream, you want to change its data type to this receive port's data type. Okay, so let's go ahead and use the async expand. If you're familiar with reactive programming using Rx, then you will probably know this function as flat map latest. So this is Dart's equivalent of flat map latest in other programming languages that, for instance, are not programming languages, but in other frameworks such as Rx. Okay, actually, specifically Rx. I think Rx calls it flat map latest, but other asynchronous programming frameworks could call it something else. Okay. So we have async expanding here. Let's go ahead and completely ignore this event, because remember, this event is an isolate. So we don't need the isolate. We actually just need the receive port, because the receive port is the responses coming from the isolate. So let's go in here and map our stream, our isolate stream, into the receive port's data. Okay. And in here, this is very important to basically say that, okay, so what data is actually coming back from this get messages? We know that is strings, right? Because every time this guy sends a string back, it's doing this send port, send now. But the isolate exit function is a little bit of an outlier in that it has this optional object, but we aren't providing it. Meaning that this exit guy is actually sending null at the end of the string to the send port. So it's literally taking, I don't actually know if we can see the source code for that. No, unfortunately, it's an external. Okay, so we can't see the source code for it, but if you go and read the source code for actual Dart's programming language, you'll see that this isolate exit takes this return value, which in this case is null. We're not providing it, and it appends it to the string. So we want to get rid of that guy. We want to get rid of that null. We don't want it. We just want a stream of strings. Okay. So what we're going to do in here, we're going to say take while, and this is our element, and we're going to say as long as the element is a string, we're interested in it. So we're going to say element is a string. Okay, so that's our conditional. Excuse me. Then what we're going to do is go ahead and use the cast function on our stream to basically return the data according to what we're returning in our function. So you can see we're returning stream of string, and this cast is going to cast our stream into that data type. Excuse me again. So what we're going to do now is we're going to put it to test. So we have this get messages, and it returns a stream of string. We're going to put this to test and see how it works. Okay. So let's go ahead in our onPressed of our text button, and let's go ahead and actually create a little function in here as the bottom of the screen indicates. We're going to call it test it, void test it. This is what I usually do when I'm testing something. Okay. And I don't mean testing in the sense of like actually writing unit tests. I'm literally testing whether a piece of code works or not. Okay. So let's go in here and say await for final MSG in get messages. And then we're just going to say MSG log. All right. And then inside this function of our onPress, we're going to remove this async because we don't need it to be async. We're just going to call test it like this. Okay, I'm going to do a hot restart in Flutter, and let's have a look and see if this actually works. So I'm going to bring up the console in here, the debug console, and then I'm going to press this button. Let's see. Here we go. We can now see 4, 5, 6, 7, 8, 9, 10. There we go. That's it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So that's how you basically take let's have a look at the code one more time, just so that I can explain it to you. So this is the main function of our isolate, all it does really, it creates a periodic stream. I have a difficult time saying periodic stream that ticks every second, and for every time that it ticks, it grabs the current date and time. Excuse me. And then it grabs the current date and time, and then we limit that intake to 10 times. And every time we get a new value, we send it to the send port. And then at the end, we quit the isolate by saying isolate exit. And that's it, really. This isolate exit appends a null value to the end of our send port. And that's why it needs the send port. You can't just say isolate exit without that, because then, yeah, no value is going to be sent through your send port. So we emit null at the end. And then in here, we're saying get messages, which is the entrance to your isolate. So we know that the result of this get messages is multiple strings. And that means a stream of string. So we create our receive port first. We spawn our isolate in this line of code, as you can see in here, and we send a send port to it so that it can communicate its messages back to us. We turn that future of isolate into a stream, and then we change its data type to the receive port's data type, because the receive port is a stream of the results that come back from the main function of your isolate. And then we take the results from that stream, the receive port, while there are strings, and then we just cast it to the result, which is a stream of strings. So it's quite simple if you have a look at the code. And again, we're using quite like a lot of maybe sometimes advanced stuff in here. We're kind of going more and more towards more advanced topics. And for that, you kind of need to know how asynchronous programming works in Dart. So I can't go into details about all of that. And I think I will create like a separate chapter in this free Dart course that talks about asynchronous programming using future and stream. Maybe future will be its own chapter and stream will be its own chapter as well. So I can't go into details about all of those, because as you know, that could take maybe more than an hour to talk about future and streams and how they exactly work. But just know that for now, this async expand just changes the type of this stream from stream of isolate. You see here, a stream of isolate. It will turn it into a stream. Actually, it doesn't show. It will turn it into stream of your receive port's data type. Okay. Perfect. Now that we've done all of that, let's go ahead and commit our work. So I'm going to go into the terminal, and let's say git add all, and then git commit step 2. And let's tag our work as well as step 2, like this. If you look at our logs, we have step 1 and step 2. Maybe you can't see it. Let me just bring Visual Studio Code a little bit higher. It's a little bit difficult to grab it here. So we have step 1, and then we have step 2. Excuse me. And then if you look at our tags as well, then we have step 1 and step 2. So that's perfect. Great. Now that we have that, we're going to go to the third example of this chapter. And I have to say, this example is going to be like one of the most advanced examples I've actually created for any of the chapters of any of the courses I've created. So it's going to require a lot of explanation, and I will do my best to do that. So I'm sure by the end of it, you will understand isolates and asynchronous programming in Dart a lot better. So what we're going to do in here is we're going to actually parse not one JSON, but we're going to parse multiple JSONs. So we're going to have one function that can just take a URL and parse its contents of type person class, and then it's literally just going to send that result, like the list of or iterable of that person object, back to us. However, from the entrance of our isolate, so that's the main function. The main function is just going to take a URL and also a send port, and it's going to parse that URL, grab instance of person, and send that iterable back to whoever called it. Whoever called it will be the entrance of our isolate. And this entrance guy is going to do some funky stuff. He's going to give, or actually is going to spawn that main function 3 times for 3 completely separate JSON files. So we're at the moment, if you look at inside Visual Studio Coding here, we have this JSON file. I think we put it in APIs, and we have people1 JSON. but we need two more JSONs, and we're going to call it people2 and people3. So that entrance function is going to pass these three separate URLs into the main event loop of the isolate and ask it to parse them. Then it's going to group these together and send it back to whoever called the entrance. So let's go ahead and create two more JSON files in here. And I already have those JSON files. It would be a lot easier if I just went ahead and grabbed those and brought them into our project. So let me go ahead and do that. So I'm going to find the APIs folder. If I can somehow, let me see if I can find it. It's, sorry about that. I'm just going to see if I can really find these three APIs, and I just found them. So I'm gonna paste them right here. So there we go. And I'm gonna show you how they look like. I mean, this is people one. So it has foo one and bar one. Then there's people two, foo two, bar two. And then we have people three, foo three, bar three. And this is really just so we can differentiate between these people instances, okay? So what we're gonna do is to clean up our code now. So let's go ahead and do that. Let's go ahead and remove this get messages from here. Okay. There's so much documentation. I can't even see what I'm doing here. This is a little bit annoying, but it shows so much documentation that you can't see your code. But this is partially, I mean, this is partially the problem, the fault of having such a big screen, like it has such a big font on the screen. So now that we've done that, the tested function is completely empty. However, we've kept the person class, okay? And everything else stays in the code. So just keep the tested function alongside your person class and you're good to go. So let's have a look in here at the code for isolate spawn. So I'm just gonna type in here isolate.spawn, okay? And let's go and have a look at its code. You can see, as we mentioned before, or as I mentioned before, this entry point function can take any object as its parameter. Up to this point, we've only used send port. However, you can pass anything in here, but anything as long as it conforms to that documentation that I showed you before. Let's go ahead and see if I can find a documentation one more time. Click on it, bring it up in here. Remember, so as long as your objects conform to these, so you can see you can send null, bool, int, double string, list map, transferable data type, send port, but just note that you can't send a receive port. So there are very specific objects that you can send to your isolates main function, and that excludes receive port. So you can never send a receive port to your isolate. So we need to make sure that we create an application or create a class that contains only the URL that the main isolates function has to download the JSON from. And it should then include the send port that the isolate then can communicate back to the entrance that created that send port using its own receive port. Okay. So this example is going to be a little bit advanced, but I'll really do my best to explain everything that is happening in it. Okay. So we need a class that contains, as I said, only the URL and the port that we can use. So if you go back in here, it needs to include the URL and the send port that the main function of our isolate needs in order to first download the URL and parse it as a JSON. And also it is going to use the send port to send the iterable of persons that it has downloaded and unparsed back to the entrance function. Okay. So let's go ahead and write the class for this guy, and we're just going to call it request. Okay. So this guy, let me just close my notes in here as well. There's so many stuff that is open. So let's go ahead and create a little class in here. It's going to be an immutable class, and we're going to call it request like this. Okay. So this request guy is going to include a send port because that's what the main function needs in order to communicate back to the entrance. So we're going to call it send port, and we're going to just say send port just like that. It needs a URI, so we're just going to call it URI just like that. I believe if we look at the documentation in here, we can send string double int bool null, but I believe that since URI, let's see, since URI is a string convertible, then we should be good to go there as well. Okay. So let's go ahead and create the constructor for this guy. So I'm going to go and get Visual Studio Code to complete this for me. And I'm going to just say this is a constant as well. And I'm not going to make these required named parameters. I think it's just enough just to say send port and URI. Okay. So now what we need is to create a get persons class that takes this request function, this request class as its input. So let's go ahead and say void get persons, just like that. Okay. And it's going to take a request in just like that. And let's just call it an async function in here. All right. So what we're going to do then in here is to actually, am I not on do not disturb? I think I should be on do not disturb. And after defining our function in here, what we have inside request is exactly what we need in order to be able to carry out the functionality of this get persons function. This get persons function really is no different from the get persons function that we created in the absolute first example that we developed in this chapter. So there's really no point in me repeating that function. All we're doing is previously we had the URL hard-coded inside this function as a constant. And we also received our port, which was our send port, as a parameter. Now those two values are inside request now. So really all we're doing is just to shift around how we're receiving our values. So I'm not going to create and write this function from scratch. I'm going to copy paste it in here and just show you how it works. You can see in here we have the exact same code as we wrote in the first example, and that's really why I don't want to write it again. However, there are two things different. One is this get URL in here, as you can see in here, that says request URI instead of basically hard coding the URI or URL. The rest is exactly the same. All of this we wrote in the first example, hence I don't want to write it again. And then in here, the second difference is that we don't have a send port, but our send port is inside this request. That's why we're saying request send port send persons. Okay, so that's how we're communicating with our entrance function. Okay, so that's what we're doing in here with the request send port. So what we need in here is this send port that comes from a receive port. Remember, receive port contains a copy of that send port. So what we need in this example really is, because we're going to call this get persons 3 times, we need 3 separate receive ports. So somehow we have to contain all this information. We need basically for every time we call this guy, we don't need just a send port and URI, but we also need a receive port. The receive port, however, cannot be sent over to this get persons object, because as it was documented, you could see in here, receive port is not one of the types that you can send over to an isolate main function. So we need another class that not only has the URI, but it also has the receive port. Okay. And we're actually, let me see what we're going to call this guy. We're going to call it persons request, I can see. Okay. So let's go ahead and create this persons request. This persons request is just a fancy class that instead of just having the send port in here, it has a receive port and a URI. Using this persons request class, we're going to create instances of this request class. Okay. I'll show you how soon. First, let's go ahead and create that little guy. Let's just call it then persons request. So I'm just going to say in here, immutable class persons request. So if you still haven't really quite grasped what this person's request is, the person's request is just an object that's going to have a port, which is our receive port, which we need for every time we call that function, the main function, and it contains a URI. Using the person's request, we're going to create instances of the request class. Okay, so it's kind of like a class that sits on top of the request, but not really its superclass. So let's go ahead and add the receive port in here. I'm just going to say final receive port. Okay, so that's that. And let's go ahead and add the URI that we are going to use to create instances of this request class. So final URI, and let's just call it URI. Let's go ahead and create a constant constructor for this guy. So I'm going to get help from Visual Studio Code to create that and make this const. All right, perfect. So that's the constant constructor for this person's request. Now we need 3 instances of this person's request, one for every API. Okay, and you can see in here, our APIs are now inside people 1, people 2, and people 3. Okay, so instead of us having to manually do that, let's just create a static function in here, call it all, that creates an iterable of person's request 3 times, basically. Okay, 3 person's requests. So let's say static iterable person request, and we call it all. Okay, and this is a synchronous generator, so we need to do it 3 times. Okay, so I'm just going to say for final I in iterator iterable generate. So we want to do something 3 times, and in here we're just taking the index and returning the index, really. So like that. So now we've created a loop that goes from 0 to and including 2. Okay, 0, 2, and including number 2. So we're now going to yield an instance of our person's request for every time that we do that. So the receive port is going to be a new instance of receive port. For every request to that main function, we need a new receive port, remember? And the URI in here is going to be, let's go to the next line. If I bring this guy to the next line here, don't worry about the formatting. Dart formatter is going to take care of that soon. We're going to say URI parse, and I'm going to grab this URI in here, paste it right there like this. And in here, we're going to say $i+1, because remember, our JSONs are people 1, people 2, people 3, but index is 0, 1, 2. So we have to add 1 to it. So we get people 1 for I of 0. Okay. So that part is done. We've now created that instance. Let's just see what's happening. So yeah, yielding is working fine as well. So we're getting the person's request in here. So what we need now is to create an instance of request out of our person's request. So we're going to go back to our request class in here, and we somehow have to be able to convert an instance of person's request to request. So we're going to create a little constructor in here. We're going to say it returns request, and we're going to call the constructor from, and we're going to say we take a person's request, call it request in here, and we say our send port is equal to the request's receive port, send port, like that. So we're just converting. And our URI is really the request URI, just like that. So now we're able to create instances of request from person's request. Okay, here. Okay, now we also need to be able to print instances or log instances of this person class to the console. So instead of just saying instance of person, it's better to implement a toString on our person class so that when we log them to the debug console, they look a little bit nicer. Okay, so let's go to this person class and add this toString. I'm just going to copy paste that. It's really not worth typing. So you can see it says string, toString, and it just says person, name is name, and age is age. So this is not rocket science. It's very easy. Okay. So what we need to do now is to go ahead and clean up our get persons function. So let's go ahead. I'll see if I can paste some stuff in here so I don't have to type all of that. So I can see here I should be able to paste some code. Let's go. So this is the main function of our isolate. Then this is our entrance to the isolate. Okay, so its return really should be a stream of iterable person. Remember, every time this main function returns its values, it returns inside. You see, this is an iterable of person. We're doing this main function 3 times. That's why it's a stream of iterable person. Every time one of these main functions emits a value, it emits an iterable person. But since we're doing it 3 times, we wrap the whole thing inside a stream. Okay. So what we need to do in here really is just to go ahead and implement the functionality of this guy. And what we need really is 3 streams. So every time this guy returns its values, we need to have a stream. Okay, and we're gonna then merge these streams somehow. You'll soon see. Okay, so let's go first, start the whole chain by saying persons request all. We know that it returns an iterable of person's request. For every one of these requests, we ideally should get an iterable of person and then inside a stream. So the stream part of stuff you saw in the previous example, how we could turn a future of isolate into the stream of its results. So if you missed that from the previous example, I suggest that you go and have a look at that, because I'm not going to explain that one more time because there was a lot of explanation. So now we have an iterable of requests. Let's see that we map this guy. You see, map it, Rick, okay, like that. And in here, for every request, what we're going to do is to create a stream of its response. So what we're going to do is to say isolate, spawn, get persons, okay, like this. And then we have the request. Cool. So let's see, actually, is it complaining about something? Oh, right. Yeah, because we can't send this request. You see, this request is a person's request, but the get person expects a request. So what we're going to do is to say request from our request here. So that part is done. Now we're spawning a new isolate. Okay. As you saw in the previous example, we're going to take this guy and make it a stream. Okay. And then we're going to do an async expand. So we just completely ignore the isolate and instead take the requests port, receive port, because that's the stream of the results coming back from the main function of our isolate. I know it's a lot, but this part we talked about in the previous example, so this shouldn't be such a huge shock for you. And then we saw that there is no exit in here. Okay, so what we are going to do is to say what we want to say, take while this element in here, we are expecting what? Iterables of person coming back from this function. So as long as the element is an iterable of person, we're good with it, okay? And then we're going to cast this whole thing. Okay, so that was a lot of code. So I'm going to say final streams, and you will see now, what is it complaining about now? Oh, sorry, not there. Here, final streams. Now, if I say streams in here, you'll see that this is an iterable of stream of dynamic. Now, you have a list of streams. How do you merge them together? How do you say, I want the result of all of them instead of having to await on every single one of them? And for that, we have stream group. Stream group is inside package async. So let's go ahead in here and import that. I'm just going to say import. So I'm going to bring up the title as well. So let's just say package. Did I write it correctly? Yeah, async Dart in here. Okay, so that's just built in. You don't have to go into pub dev and import it manually. It's already there. You just have to import it. Okay. So in here, after doing that, since we have an iterable of stream of dynamic, we want to merge the results, and then you should use stream group. Oh, we should probably say show stream group. Yeah. And after doing that, we can go to our group, code, and say stream group, as you can see, and then we're going to say merge, and we have our streams. So all we have to do really is just to return that guy from here. So we're going to say return, and we just cast it just like that. So that was really it. Let's go ahead and save this file. I'm just going to command shift Alt F5, all of those. I don't know. It's a hot restart, I think, in Visual Studio Code. I don't even know which commands, like which keys I'm pressing. I'm just pressing them because I know how they kind of like feel on my fingers. But I think on Mac is Command Shift Function F5 on in Visual Studio Code, and on Linux and Windows it should be Control Shift F5 to do a hot restart. Okay, so now that that is done, let's go ahead and actually consume this guy. And let's go to our test it, and we're gonna run some code inside our tested function. I'm gonna copy paste that so I don't have to type it because this is the boring part. So you can see it says await for final MSG in get persons. Okay, and then it's just gonna log it. Remember, MSG is now an iterable of person, right? So let's bring up the debug console and have a look at actually in the debug console it should be. So I'm gonna bring the app up. I'm gonna press this button, and you can see now we see the result of all three streams combined into one, and we're seeing the first emission says foo1, and then bar1. Then the third stream for some reason succeeded first before the second one, and we got that stream's result, and then we got the second stream's result. So that's basically what I wanted to demonstrate. And what you could do, you could experiment in here. Instead of using the send port, what you could do is instead say isolate dot exit, and then use your request send port and send your persons in here. So instead of request send port send, you could do this code. I'm going to do a hot restart and bring up Visual Studio Code. Let's see how this guy reacts. So, and you can see basically get the same result, but using isolate exit is a cheaper way of sending values back to your entrance, and that doesn't really copy the code. Instead, it reassigns the memory for the object that you passed your isolate exit to the entrance function. So I actually suggest that you use isolate exit to pass data back to your entrance function instead of using the send port send function if you can. Okay, fantastic. Now that this example is done, let's go ahead and commit our code. So we're going to say git add all, and then git commit step 3. And let's also tag our code. So git tag step 3. Okay. So we've gone through a lot of examples. I mean, there are 3 examples. We started very like soft, and then the third example was really hardcore. There was like a stream of like iterable of streams, and then stream groups that you may have not used before. But I think it was worth basically going through all these 3 examples to see how isolates really work in Dart. So just to review things, you have an entry function that is your consumable isolate. You have the main run loop of your isolate, which the entry spawns using isolate spawn. Then you have a receive port, which is read write created by your entrance or the entry. And then you have your send port, which is a write-only variant of your receive port, which is consumed by your main function or the main loop of your isolate. And then you have this concept of the send port being able to send various values back to the spawner. And you have the possibility to also use isolate exit to send non-copied values back to the entry function. So lots going on, and I really suggest that you go through these 3 examples again and study them yourself, and also write the code yourself so you get a good hang of isolates. They're really fun. So I hope that you enjoyed this chapter. I had a blast making this chapter. I thought it was really fun actually to put it together. I also personally learned as I was creating this chapter, so I hope that you enjoyed it. If you have any questions, let me know. And don't forget, we have a Discord group for the free Dart course. So you can click on the link in the description, which leads you to the playlist of this Dart course. And in there, in the description of the playlist, there is the Discord group available, which you're more than welcome to join if you have any questions about this particular video or any other videos in these series. So hope you enjoyed this chapter, and I'll see you in the next one.